All right. Hi, my name is Dr. Prickett, and this is going to be the first lecture video for Linguistics 409. So let me just go ahead and get started with the slides. Obviously, you can't ask questions since this class is asynchronous, at least not live questions, but do keep track of anything that doesn't make sense or concerns you have. Always feel free to email me if anything doesn't make sense. We'll hit on that a few times today. So let's get started with some class introductions. Oops, well, there we go. Now let's get started. All right, so first off, who am I? My name is Brandon Prickett. I got my PhD in linguistics at UMass back in 2021. I don't technically have the title of professor, so I know it's kind of hard to keep track of who of your teachers are professors and who aren't when you're going through undergrad. So just so you know, I'm not one of the professors. I'm just a doctor. So you can call me Dr. Prickett. I won't get mad if you accidentally call me Professor Prickett or Mr. Prickett or Brandon or anything like that. But just as a default, Dr. Prickett works. My dissertation, which you probably know is the book you have to write to get a PhD, was actually on computational linguistics. So that's why I'm teaching the class. Specifically, I focused in on the subfield of phonology, which if you've taken Linguistics 201, you know is the study of sound patterns in language. And what my dissertation zoomed in on within that subfield was looking at state-of-the-art machine translation technology, so the kind of stuff that's like under the hood of Google Translate, and seeing what that kind of technology can tell us about first language acquisition of phonology. Outside of linguistics, it's probably good for you to know that I'm not in Massachusetts. I live in North Carolina with my wife and daughter and dog. And when I'm not doing linguistics, I'm usually like going on walks or watching Netflix or playing video games with some combination of those three entities. So let's talk about the goals of the class. This course is an introduction to computational linguistics, and that is, as you probably have guessed, a subfield of linguistics that explores natural language use using computational tools and perspectives. So we're going to be stepping through many, though not all, of the major subfields in linguistics, and within each subfield, seeing how computational approaches can help to inform our understanding of each one. So a variety of theoretical approaches is going to be considered. So things like constraint-based grammars, context-free grammars, neural networks. Again, some of y'all who've taken Linguistics 201, probably most of y'all who have taken Linguistics 201, know what context-free grammars are. You probably learned about those in your syntax unit. But constraint-based grammars and neural networks might be a little bit less familiar to you. So we'll get into all that when we get to it in the course. But they're all things that are, like I said, ways that computational tools can be used to help explore natural language. And then we're going to have four main learning objectives. So we're going to want to look at empirical phenomena. So we're going to explore selected linguistic phenomena from a computational perspective. We'll have theoretical intuition that we're wanting to build in each of you. So we want you to get exposure to some foundational concepts in computational linguistics. We want to also build your computational skills to acquire basic abilities when it comes to programming. And we want to give you a taste of research. So we want you to practice developing small, reproducible coding projects throughout the semester. And when I say we there, I mostly mean me. I got some input on the curriculum and everything, but that made it sound like there was more than one teacher. It's just me. So one other thing to talk about while we're right here at the beginning of the slides, if you have a disability that affects your participation in this class, please do bring it to my attention at the beginning of the semester, or at least as soon as you can, so that we can make any necessary accommodations that we need to. I also understand that sometimes disabilities pop up in the middle of a semester, right? Or flare up in the middle of a semester. Let me know when it happens as soon as you can, so that we can accommodate anything you need accommodated. Always happy to do that. All right, so like I said before, this course is asynchronous. So that means that all the lectures are going to be recorded. And what that means is that everything you need is always going to be right on Moodle, which is the website UMass uses to host all of their kind of academic stuff. So we have a course website on Moodle. You'll have your lectures linked to there. If Moodle ever isn't working, just contact UMass IT first. That would be the kind of best solution, probably. You can let me know, obviously. I'm not going to be annoyed that you're emailing me to tell me about Moodle not working. And in fact, I'll probably appreciate it. But I probably won't be able to fix whatever's going wrong, whereas the IT folks probably will be able to. And if it ever seems like the issue is going to affect your ability to turn your work in on time, definitely let me know so that I can provide you with an extension, right? I don't want Moodle crashing and that causing you to get a penalty in your grade or anything like that. My email address is right here. So it's B as in Brandon, and then Prickett, my last name, at umass.edu. No linguist in there. I know some professors in the department have linguist in their email addresses, so be careful about that. It's just bprickett at umass.edu, and Prickett has 2 T's in it, so be careful about that as well. I'm always going to try to respond to emails within 48 hours of receiving them. I'll probably be a little slower on weekends, but sometimes I'm also that fast on weekends. If 48 hours has passed, or if something's really urgent and it's been 24 hours and you still haven't gotten a reply from me, feel free to email me again. That's never going to annoy me or anything like that, right? I understand that sometimes emails go to spam folders or slip through the cracks some other way. So if you feel like that might have happened to your email, don't wait a whole week or something like that. Just shoot me another email and you'll probably get my attention then. If you think that maybe the email went to my spam folder because that happens to you a lot or something, try emailing me from a different account. That's also a good idea. And like I said before too, if you ever have questions, if you've got feedback, right? If I'm like going too fast in the videos through the slides, if the slide font is too weird or too small or anything like that, shoot me an email and let me know. Just like you would if we were there in person in class and you were able to raise your hand and give me that feedback. Last bullet here, I'm always happy to meet in a kind of office hours sort of way. Although, like I said a couple slides ago, or maybe one slide ago, I live in North Carolina, so I don't have a formal office there in the linguistics department at UMass. But if you ever need to have an office hours style meeting where I walk you through some of the stuff we've been going through, or I help you out with debugging your code or something like that, that is totally okay. I'm not going to have a set time for that, just because my schedule is pretty flexible. And I think if I had a set time for that, it would really be taking away from y'all. So email me if you want to do an office hours meeting, and we'll just set up an appointment over Zoom. I'll send you a Zoom link. We'll do it that way. And that'll be how office hours happen. Now let's talk about the structure of the course. So I think this is the third time I've said this, but the course is obviously entirely online, and it's also going to be asynchronous. That means that none of the lectures will be live. There are no required live meetings you have to go to. Office hours will be live if you want to go to office hours, right? But those aren't required. And what that means is that Moodle is like your one-stop shop. It's going to have all of your assignments, all the lecture recordings, all the readings. They'll all be right there on our Moodle page. Class lectures are going to be recorded to YouTube via the site's live stream feature, at least if that works out. I'm trying it this week, and we'll kind of see how it goes. What this is kind of meant to do is to help me avoid the temptation to edit these lecture videos. So the videos are going to get kind of long, and if I was spending time making the slides for them, then recording them, then editing them, and then uploading them up to Moodle or YouTube or wherever, that would take me probably all week just to do the lecture. So I'm trying to do this as a little bit of a time-saving technique, and I'm just going to treat it as if I was giving you a live lecture. So that means you might sometimes hear some noises in the background, right? Just as if we were having a live lecture. So you might hear my baby crying, my dog barking, things like that. Apologies ahead of time for anything that's distracting. If I think that it's so loud that you can't hear me well, I'll do exactly what I would do as if we were in like a classroom. I'll just pause until the noise is done. And if I need to go like find the source of the noise and turn it off or something, I'll go do that. I'll come right back, get back into the lecture. So bear with me if that happens, but it's going to save me a lot of time on editing. So thank you ahead of time for understanding as far as that goes. Another thing is that since I'm doing that, doing them directly onto YouTube, I'll just link them onto Moodle. So the actual video files won't be downloadable for you, but they will be always there. I'm not going to like take them down after a few weeks or anything like that. I'll leave them up the full semester. You'll be able to go back and rewatch them if you need to or anything like that. If you ever have any issues accessing them or issues using YouTube or the YouTube quality is bad, let me know about that as soon as you can, right? Because if you're having problems, other people probably are too. Most weeks, right now, I'm planning on having 3 different kinds of lecture videos, so like 3 separate videos for the week. There'll be a video reviewing any assignments we had the previous week, so we obviously don't have that today because this is the first week of the class. We'll then have a video giving a lecture about whatever linguistics material we're learning that week. So that's kind of what this is. We're going to obviously get through the syllabus here today, and then we will actually learn a little bit about the history of computational linguistics today. So there will be some linguistics we actually learn about. So that's what this video is right now you're watching, is the lecture video, the linguistics video. And then there's a third optional video I'll make each week that's going to be going through whatever programming skills we're trying to learn that week and that you'll need for the upcoming project usually. So this is going to depend on your prior programming experience, how much I would recommend you watch these. If you've never done any programming before, that's totally fine. This class doesn't assume prior programming experience. But if that's the case, I would just watch them all if you're in that kind of situation. If you do have lots of programming experience, right? Maybe you're like a 4th year computer science student or something like that. You know Python like the back of your hand. You can probably skip almost all of the Python lectures. If you're somewhere in the middle, I'm going to put what each lecture is about in either like the title or the description of the video on YouTube or Moodle, maybe both. So just check out wherever the description is. I'll list out all the topics I'm going through. If you see a topic you don't know, you can go watch the video. If you know all the topics already, like the back of your hand, don't worry about it. Totally an optional part of the class for folks who are already familiar with programming. What I would recommend for your kind of workflow in the class is that you would watch the videos first in that order. So first watch whatever video that week reviews the assignments from the past week, so you kind of know where you're at with the work you've done. Then watch the linguistics lecture, because that's kind of the core of the class, right? That's what you need to do. That's the obligatory part. And then if you're going to watch the Python lecture, watch that one last, because sometimes the Python lectures, I imagine, will reference the linguistics lecture for that week if we're kind of implementing some idea from the linguistics stuff we talked about. So best if you just kind of go in that order. Then after you finish the videos for the week, that's when I would work on that week's assignments. And I'll get into more about how the assignment schedule is going to work in a couple slides, but I would just always watch the videos before I work on the assignments, because the videos are going to tell you how, essentially, to do them. All right. So now let's talk about those assignments and what they're going to look like and when they're going to be due. So assignments are due at 8 a.m. on the Monday following whatever week they're listed under in the syllabus. So I've tried to draw this out on this calendar over here, but for example, the vowel plot project is listed under this week here, the week of the 20th in the syllabus. And what that's going to mean is that the vowel plot project is due by 8 a.m. on the following Monday, so Monday the 27th. So we've got our first week of classes here, right? You don't actually have anything to turn in this week. I just want you to review the syllabus. Your first assignment is going to be given to you the week of the 13th. That's going to be a reading assignment and a quiz. And so that reading assignment quiz combo will be due on the 20th. Then you'll be given the project. That'll be due on the 27th. You'll be given something else that week. That'll be due on the 6th of March, and so on and so forth. So make sure you kind of keep track of that. I know that being an asynchronous class, due dates are sort of weird and odd anyway, but just try and keep track. And if you have trouble keeping track and it's a weird thing, email me and we can kind of talk about it and maybe figure something out. But that's what it is right now, is it's going to be a week after the Monday that it's first assigned, or that it's assigned in the syllabus. Any late assignment is going to do the kind of normal default thing. It'll lose 10 points for each day it's late, and if anything's more than a week late, it's not accepted. Accommodations and exceptions to those policies should be discussed with me when you can, before the due date, right? So I know stuff is going to happen, and sometimes that stuff happens so far in advance, or not far advanced enough, that you can't tell me ahead of time, and you just have to turn something in late and then ask for an exception. I totally get that, and I'm not going to be upset if you do that. But if you can tell me something, if you know that, oh, hey, I've got like a surgery that week, so I know I need an extension. I know I need an extension that week. You know, weeks and weeks ahead of time. Let me know when you can. That would be nice to know ahead of time that I need to give you an extension. Also, don't feel like you got to tell me a ton of personal info. I'm not a detective. I'm not a cop or anything. You don't have to tell me like your whole alibi for why you can't do the assignment on time. Just, I was sick, or I had a death in the family, or I had this thing for my job. Those totally work. And I understand that happens. I'm never going to begrudge you an extension or anything like that. So happy to be flexible. All right. So that's about due dates and late work. Now let's actually get into the types of assignments you're going to have. So let's talk about readings and quizzes. These are going to be 25% of your grade. So there's no textbook for this course. Instead, we're going to be looking at published peer-reviewed papers in computational linguistics. So you're going to get kind of like a real-life experience or peek into the field of computational linguistics. The papers are all uploaded to Moodle as PDFs. If you have issues accessing any of them, or reading the font, or they're too blurry or anything like that, let me know and I'll get you a different version. Since these are actual computational linguistics papers, and you're all presumably being introduced to computational linguistics for the first time this semester, don't feel like you need to understand everything that the papers are saying. Please do not turn the readings into this kind of like stressful torture session, right? That's not what I want. I want you to just read through. As long as you can actually read the words, you're doing well. But each reading assignment is going to have a quiz that'll ask you about the information that's actually important, that you actually should be getting from each article. And the quizzes are going to be open article and open note and multiple choice. So the general workflow I would recommend for your readings and the quizzes that go along with them is to read through the article and take some notes on it as best as you can. Again, don't torture yourself trying to make sure you know what every single math equation means or anything like that. Just take some notes, read through the article, have the article and your notes ready with you before you start the quiz, and then take the quiz using those as a guide. So not the kind of thing where I'm having you write an essay based off of this article or any kind of open-ended exam or anything like that. I only want you to know what the quiz asks you about. So that's all you need to worry about. All right. Next thing to talk about is the projects. So this is the biggest part of your grade. It's 50% of your grade. There's going to be 5 total projects over the course of the semester, so they'll each be 10% of your overall grade. They're designed to give you experience in computational linguistics by performing tasks that computational linguistics actually do every day in their research. So all of the projects involve coding in the programming language Python. Like I said before, I don't assume any prior coding experience in the course. I'm going to be walking you through all the skills you need to know in those separate Python lectures. Also, like I already said, if you already are a really experienced Python programmer, you can just glance at the description for those lectures and decide for yourself whether you think you need a refresher on that topic. We're going to be doing our programming in Google's Colaboratory service, so it's often shortened to Colab. It's basically just this way to run Python programs in your web browser in a really intuitive, easy-to-use way so that you don't have to worry about downloading Python onto your computer. That can get really complicated and annoying depending on the operating system you have. So that's not something we want in an online class where I can't sit there and show you how on my computer in person. So we'll be using Google Colab for all of our projects. And for the first project, you're going to need one more piece of software called Praat, P-R-A-A-T, which you are going to need to download. You don't need to worry about that yet, though. That week's programming lecture is going to have a little section where I tell you what Praat is, how to download it, how to use it for what we're going to be using it for. So no need to worry about Praat yet. That'll just be one of the things one of the extra pieces of software you're going to have. I guess that's maybe the only kind of software you'll need to actually download. All right, and then the last kind of assignment is exams. So these are only going to be 25% of your grade, so half as much as the projects are. So not something to stress out a ton about. There'll be a midterm and a final. And what these are mostly going to test you on is the material in the linguistics lectures. So the quizzes are all about making sure you do the reading assignments. The projects are going to be involved in the linguistics material we learned, but there aren't enough projects to test you on every single piece of the linguistics lectures, right? So in addition to the projects teaching or testing you on the linguistics lectures and your Python skills, we'll have the exams really focusing in on all the little things that we learn in those linguistic lecture videos. And that's another reason why they're obligatory. You've got to watch all of those. So the exams are going to be multiple choice. There'll be some short answers. There'll be some longer exercises involving maybe like diagrams or examples or a little bit of math. I haven't made them yet, but something along those lines. For the exams, you're also welcome to use your notes and the assigned readings as a resource. The readings probably won't be very helpful because the exam is really going to focus more on the lectures, but feel free to have them out and ready in case you think they'll be helpful. And definitely have your notes handy. What you can't use is Google or any kind of external source. So what the exams are trying to see is if you've watched those linguistics lectures. So I want you to not be Googling what the answers are, but if you want to look in your notes that you took when you watched the lecture, that's totally fine. And the university's academic honesty policy is linked there. If you want to go check it out, you can. But I'm just treating any use of external resources during the exams or the quizzes as well, right? The quizzes, you're only allowed to use your notes, and the reading assignments, not Google. So any external resources like Google, or if you like found a textbook or something and were using that, that's going to be considered cheating. Don't do that. If you really feel like the resources I'm giving you aren't enough, that's okay. Email me and we'll work something out. That isn't considered cheating. The way the exams will work logistically is I'll give you a PDF on Moodle. You'll download it, and then you can either print it out, fill it out, scan it in, and upload it, or just directly edit the PDF on your computer and upload the finished exam to Moodle from there. Don't really care about whether you're handwriting the test or typing the test. Those are both fine. All right, so that's all of the kinds of assignments you'll have. So just to kind of review, I know I showed them separately, but 25% for readings and their quizzes, and really it's just the quizzes that you get graded on, 50% for the projects, 25% for the exams. Now let's look at the schedule a little bit and go over this. I won't go into super fine-grained detail here because not all of these things are you going to understand quite yet. But if you look in this syllabus, that's what this is a screenshot of. And this is just the February section of the schedule. But you can see here's this week. The week of column is always going to give you the date for that Monday. So I know Sunday is usually considered the start of the week in America, right? But I'm kind of using Monday as the start of our week because it's a little easier to keep track of in my brain. So Monday is going to be the date that's over here in our first column where it says week of. Those are all dates for Mondays. Here it tells you the unit we're on. So we're not really in a unit yet, right? We're just doing introductions this week. But then we'll get into the first unit, phonetics, and start the second unit, phonology, in February. This tells you the topic of linguistics lecture. So again, a lot of these words are just going to be kind of word salad to you, but just gives you a hint, right? If you've taken 201, you probably will understand a decent amount of those words. And so you'll know what's coming there. This next column is important because this is another place you can look if you have some programming experience with Python and want to preview the Python lectures before you actually watch them to see if you'll actually learn anything from them. So this gives you the topics we're going to go over in that week's Python lecture, and you can check it beforehand to see whether you want to check that out. And then the last thing here is the assignment. And like I was saying, so, oops, go back. There we go. Sorry about that. So like I was saying before, the week that the assignment is listed in is telling you the due date minus 7, right? So for example, this reading here, the Milka 2005 reading and the reading quiz that goes along with it is assigned to you on the week of the 13th. So it's due at 8 a.m. on the 20th. The vowel plot project was the example we used before. That's assigned to you on the 20th, or the week of the 20th, and it's due by 8 a.m. on the 27th, and so on and so forth throughout the whole semester. The way breaks will work is we'll kind of pretend those don't exist. So the week before a break, the assignment will be due the Monday after the break is over. All right, so you've got your first reading assigned to you next week, and it's got a quiz to go along with it. The week after that, you'll have your first project assigned to you, the vowel plot project. And like I said in the Python programming lecture we've got that week, you'll also be learning about Prot, how to download and use it. So even if you're a Python expert, if you've never used Prot, definitely watch that video. It's not an intuitive piece of software, but it is one that's really influential in linguistics, so it's important that you know it. After that, you'll have another reading and reading quiz, and that's going to be the start of the phonology unit. So that's a phonology paper you'll be reading through. Then we'll get into March. March is where UMass's spring break is. So like I was saying, you've got a project here assigned to you before spring break. It's not going to be due until 8 a.m. on the 20th. So you'll have a little bit of flexibility there in terms of when you get that done. After you get back from spring break, you'll have one more phonology paper to read with a quiz that goes along with it. Then we'll start our morphology unit. There won't be our morphology reading, though. So we've got the midterm exam assigned to you that week. Instead of you doing a reading or a project or anything like that, you'll just be doing your midterm exam. And remember, that's just open note, download the PDF, fill in the answers, upload it. No programming lecture on the weeks that exams are assigned. So you get a little bit of extra time to actually study for the exam, do the exam, whatever your workflow is like. Then into April, we'll finish off the morphology unit with a project. So this project will be for that unit. And then we jump into our syntax unit. That, like phonology, is going to go reading, project, reading. So you'll get 2 readings on syntax, and they'll each have quizzes to go along with them, with the A project in the middle. Then into May, so since our semester got started a little later than it kind of usually does, it goes a little later than it usually does too, right? So our last week of classes isn't until the week of the 15th. So our last kind of proper unit is going to be semantics, and you'll have a reading and a project in that unit. And then our last week, we'll have a lecture on bias in NLP. So that's like how computational linguistics findings and applications can sometimes make biases that people already have sort of worse and more impactful in the world, and materially make people's lives worse, things like that. It'll be kind of a bummer, but we'll talk about possible solutions to those issues at the very end of that lecture. So we'll end on a slightly high note. Then you've got your final exam assigned to you that day. And so again, there's no programming lecture to watch that week. All right, so that's the information that's on the syllabus. Again, your homework assignment this week technically is to review the syllabus. So do look at that yourself, go over it, make sure you understand anything or everything, and email me if you've got any questions. But now we are going to move on to some actual linguistics, like I was saying. I always like to open up classes with a little bit of a historical overview of the field or topic we're going to be talking about, because I think it gives you a sort of nice bird's eye view of everything that we then go on to learn throughout the semester. So we're going to learn about the sort of very broad strokes of the history of computational linguistics before we actually go throughout the rest of the semester and learn about how to do computational linguistics. All right, so let's talk about pre-20th century computational linguistics. So language and computing have been intersecting for centuries, as long as you have kind of a generous definition of computing. So here I just mean generally applying some kind of algorithm, right? Which algorithms have existed for a lot longer than computers probably, So that's how I'm getting away with saying computational linguistics has existed before the 20th century. So, for example, codes like the Caesar cipher and I'm going to pronounce this wrong. It's something like Vigenere cipher. These were ways of encoding and decoding messages that were used by spies and military commanders and folks like that to algorithmically kind of hide sensitive messages since at least the 1st century CE. The Caesar cipher is called that because it was reportedly used by Julius Caesar. So here's actually an illustration of that, right? It was a very simple thing. You just shift over the alphabet a couple of characters or a few characters and write out your message using your new alphabet. So something that can be done with computers very easily now, but maybe was a little bit more tedious back then. In the 18th century, so fast forwarding pretty far here, I'm also going to pronounce this pretty poorly, Gottfried Leibniz, who was the co-creator of calculus, right? So him and Isaac Newton both created calculus at around the same time independently. He sought to invent a writing system that was purely logical and could be used by anyone regardless of the language they spoke. He envisioned it as this language that mathematicians and scientists could all use to talk to each other. But what he was kind of describing was essentially a computer programming language. And so that is also, again, kind of like getting close to being related to computational linguistics, right? Not quite what computational linguistics really concern themselves with, linguists concern themselves with, but a step in that direction. Then in the 19th century, mathematical logic emerged, which is absolutely something computational linguists nowadays think about and work on. So that was a way to formally describe the way that philosophers use language in their arguments, essentially. Or at least that's what it was kind of originally made to do. And we'll be talking about a little bit of formal logic when we get into the semantics unit this year, so we'll definitely get a taste of that. Also, the 19th century saw Ada Lovelace, who, if you've never heard of her, she was a countess living in England. She wrote the first published computer program. And it was, again, somewhat related to computational linguistics, right? Since a computer program is a way to communicate instructions and information to a computer. So leading up to the invention of the kind of digital computers we have now today, we saw people sort of constantly having to use algorithms and computing and math to deal with language, but never in a kind of organized, central way. And that's because computational linguistics didn't formally coalesce into a field of study until the mid-20th century. And like a lot of subfields in linguistics, so if you're involved with anything, or maybe you're going to go on to learn more about different subfields in linguistics, they almost always grow out of two different scholarly communities. So for example, linguistics field work, where you're going out and documenting languages, kind of grew out of both linguistics and anthropology. And in a similar way, computational linguistics grew from linguistics. So there were linguists who were interested in formally characterizing the different steps that were necessary to learn a natural language. And then there were computer scientists who were interested in simulating human behavior, with software. And one of those behaviors they wanted to simulate was humans' ability to use language to communicate. So in the 1950s, right as these kind of ideas were starting to bubble up, two leaders in these groups made contributions that still impact the field today. So there's Alan Turing. You might have heard of him. There's like a movie about him and stuff starring Benedict Cumberbatch. He was a computer scientist, and he did lots of stuff for computer science. But one thing he did for computational linguistics was to propose the idea of the Turing test. So this was meant to be a metric for determining whether a computer was human-like in its intelligence. And the test was having a human converse with another entity that they didn't know, I'm about to make an ungrammatical sentence here. They were conversing with someone and they didn't know if that someone was an actual person or was a computer, right? So you do this test and then you ask the person, hey, were you talking to a computer or were you talking to a human? And if that person can't tell, if the computer is indistinguishable in its ability to converse with you from a human, then it's passed the Turing test. and it does have human-like intelligence. There's all kinds of problems with this metric we know now today, right? We're like 70 years later now, so we have a better idea about what it takes to have human-like intelligence, but that was still a really, really influential thing that Alan Turing did when he proposed that. Another big thing in the 50s was from Noam Chomsky. So he was a linguist, and one of his big contributions to the field of linguistics, one of his many big contributions, was to introduce what's called now the Chomsky hierarchy. So this is a way to formally define the complexity of a language's grammar. And it's essentially, you're saying how complicated a grammar is using math. And it's still regularly used by linguists today and in lots of stuff, as well as computer scientists. So UMass's computer science department actually has a class on the Chomsky hierarchy. That's how influential it was in that field as well. And by the early 60s, the first piece of computational linguistics related software, at least that I know of, was created. This was called ELIZA, and it was an attempt at passing the Turing test. So this was a piece of software that would chat with you, what we would call nowadays a chatbot, and it just used simple rules to simulate a conversation. Then we get to the 80s and 90s, and things become a little bit more argumentative. So some big achievements happened, but also some big kind of battles happened between camps in the field of computational linguistics. So in 1986, two psychologists created software that could somewhat successfully learn how to convert present tense English verbs into their past tense counterparts. So it could go from walk to walked, jump to jumped, bug to bugged, but also like sing to sang. And instead of using grammatical rules to govern the program's behavior, these psychologists used a newly popularized system called a neural network that was designed to simulate the neurons in a brain. So instead of saying, oh, add ed, except if you're this word, then do this other thing, right? Instead of explicitly programming that, they had these simulated neurons that kind of learned that pattern after seeing a bunch of English verbs. This created a little bit of a backlash from both linguists and other psychologists who felt like you needed those strict, explicit rules to accurately reflect what humans do when they learn language. So there had been a kind of status quo before this that, well, of course, we've got these rules written down in our brain that looks something like a grammar book that you get in elementary school, right? That must be how our brains work. Look how rule-following language is. So that was kind of happening on one end of the spectrum. On the other end of the spectrum, computer scientists had made a lot of advancements on a number of language-related tasks in the 80s and 90s. So they got a lot better at speech recognition, machine translation, automatic grammar checking, like you have in Microsoft Word where it gives you the little green line. All of that stuff was a lot better off in the 90s than it had been in the 80s and 70s and 60s. But a lot of that work in computer science was done without the help or feedback of linguists. So it was kind of divorced from the field of linguistics, even though it was dealing so much with language. And there's this famous quote from the late 90s that sort of summarizes the reason for that divide. So there's this guy, Frederick Jelinek, who in 1998 at a conference said, every time I fire a linguist, the performance of the speech recognizer goes up, which was this joke he was making about the fact that oftentimes linguists, when they're trying to make a speech recognition software or machine translation software, they end up getting kind of distracted by the science of it, by like understanding how humans do translation or how humans recognize speech, instead of just building software that kind of gets the job done. And so, yeah, so that's a famous joke to know about if you're interested in computational linguistics. That's one of the big things people talk about in this field. Then we get to modern day, or at least modern-ish day. So starting in the 2000s, there was a big boom in the field of computational linguistics generally. And when I say that, I mean computational linguistics done by linguists, where they're really concerned with how humans acquire language. And more specifically than that, the 2000s saw a big boom in the field of computational phonology. So like I said, I care about this because I'm a phonologist, right? So I'm a little biased, but I think phonology saw one of the bigger kind of growth spurts during this time, computational-wise. And in part, that was because a new theoretical framework that was based on neural networks called optimality theory had become really, really popular in all corners of phonology. And in the computational corner, it made learning sound patterns much easier to simulate. So at the same time that that was happening, or maybe a decade later, computer scientists saw sort of a boom of their own. So in 2012, there was this really famous project that was competing against other projects to see who could do the best on this particular kind of contest. Computer scientists like to have contests. And what they did is they showed the winners of that contest that a neural network that is complex enough and given enough data to learn from can dramatically outperform other kinds of artificial intelligence software. So this was in the domain of picture identification. So the contest was, hey, here's a bunch of pictures, see how well your software can label them in terms of what they are. Like, is it a horse? Is it a chair? Things like that. But they demonstrated just kind of this general principle that a bigger network with more data can do really impressive things. And that was quickly generalized then to linguistic tasks as well. And that's where we get things nowadays that we'll be learning about in this class. If you don't know about this yet, that's okay. But things like large language models, if you've heard of like GPT chat, things like that, are essentially all grandchildren of this idea that was first demonstrated in 2012. Then in the last decade, what you see is a lot of linguists kind of reacting to that. So saying, hey, we've seen that neural networks can do these things in terms of mimicking human behavior that we never really had thought were possible using that kind of technique, right? Using a technique that doesn't have explicit grammatical rules in it. So a lot of linguists have adapted to that. They've said, okay, neural networks are successful. Let's use these to kind of guide our own research, right? Maybe that's not exactly what's happening in a human's head, but let's use it to kind of see more about what might be happening. At the same time, you still have many linguists who are in that same camp that they were in the 80s and 90s, right? And I'm not trying to like paint them as backwards or anything like that, right? They've got reasons to be in that camp. There are certain things that neural networks can't do. And so these linguists maintain that a more rules-based approach is necessary to actually capture how humans are acquiring the ability to use and understand language. So that's the end of our linguistics lecture this week. Again, if you've got any questions, if there's anything like font size or audio quality or anything like that that I need to improve on, please let me know. Send me an email. And check out the Python lecture, or at least check out the description of it if you already know how to program in Python to see if you want to watch it. There'll also be one of those there in Moodle for this week. All right. I will see all of you in the Python lecture.